Whoa.
Grace?
Okay. Hi.
Hi, how are you?
Good, how are you?
Good. Sounds like you have a dog in the background. Usually my dog responds to that. I'm surprised she's not down here.
Yeah.
Alright, so what are we working on today?
We have to go back to that website. Do I have to copy and paste the link to you too?
No, I have it saved, I think. No, wrong one. CPM ebooks, right? Username is GR1. GR1. What's the password?
And then 2076. Okay.
Chapter
7. 7.2.1. And then 792. Or 91. 91.
Okay. You have the cube root of minus 64. So, what number, when multiplied by itself 3 times, is equal to minus 64? Is it going to be a positive or a negative number?
Negative.
Correct. And you always know that these are always going to be whole numbers. They're not going to ask you these kind of questions unless they're whole numbers. In other words, it's not going to be like 4.126 or something. So, all you have to investigate is a couple of whole numbers. Is it 2? Is it 3? Is it 4?
4.
Or is it negative 2, negative 3, or negative 4?
Negative 4.
Correct. Okay, what's the 5th root of 32? Positive or negative?
Positive.
Okay.
2.
Uh-huh. And the cube root of minus 8. Positive or negative?
Negative. Yeah, negative. 2. Negative 2.
Okay. And the last one. Notice the difference between the last one and the previous ones. These are all odd roots. This is an even root, which means it's going to be plus or minus something. Odd roots are either plus or they're minus, but they're not both. But even roots are always plus or minus. So what's this one going to be?
Is it 700 times 5? No, 10?
Yeah. Notice that 10 times 10 times 10 times 10 is equal to 10,000. Also, minus 10 times minus 10 times minus 10 times minus 10 is also equal to plus 10,000. And that's why the answer is plus or minus 10. In other words, whenever you take even numbered roots, you're going to get plus or minus. When you take odd numbered roots, you're going to get either plus or minus, but not both.
Okay. And then 791.
Okay. When you want the equation between 2 points, what's the most important thing to figure out first?
Where x and y go?
Well, what is the slope? We know that the equation of the line is y equal mx plus b. Well, the most important part of that is the m, the slope. So let's figure that out first. What is the definition of slope?
Rise over run.
Okay. What's the rise here? You
16.
Well, it's really the difference in y values all over the difference in x values. What is the difference between 16 and minus 4?
12.
No. That would be 16 and 4. But 16 minus a minus 4 is how much?
20.
Okay, so that's the change in the y. What's the change in the x?
9? No, 5.
5. So the slope is plus 4. Now, it doesn't, as long as you go the same direction, that's what's important. In other words, as long as we took 16 minus a minus 4, then we could take 7 minus a 2. Had we decided to go the other direction, then you have to be consistent. I could have said minus 4 minus 16, which would give you minus 20, and I could have said 2 minus 7, which would give you minus 4. Notice it is the same slope. So it doesn't matter which direction you go as long as you're consistent between your x's and your y's.
Okay.
Okay, so we have a slope of 4. What's the general equation for a line?
Y equals mx plus b.
Well, we know m. If we can solve for b, we'll be done. How can we solve for b? Now, you might have done this 2 different ways in class. You might have used the point slope formula, or you might have used the slope intercept formula. I don't know which one you've used. But you can...
I just plugged the points into the equation.
That's fine. So let's do that. So pick one of those points and plug it into this equation, and we'll solve for b.
I did 16 equals 7m plus b, but that doesn't look great.
Well, because our slope is 4, so it's 4 times x, which is 7, plus b. So actually you were right. In other words, pick one of the points and plug in the x and y value into this equation, and this is going to allow us to solve for b. So what is b equal to?
It's a negative number.
Negative 12. So now, what is our specific equation for this problem? What's the slope?
4.
What's b?
Negative 12.
Notice that the specific equation still has an x and a y in it. In other words, our goal was to solve for the slope and b. Once we did that, then we go back and we put both of those in. So this is the equation of that line for 91. 2 points determine a line. They gave us 2 points. There can only be one equation that fits that line. Okay. What next?
Yeah. 7.2.2. And then scroll down to 796. It's kind of like the same thing, but
A little different.
not.
Well, the difference is the fact that this is an exponential equation, not linear. In other words, linear we know is a straight line. The only thing you need to define a linear equation is 2 points. When you have 2 points, that's all you need. That defines a straight line. When you're talking about an exponential function, you're talking about something that looks like that. Well, 2 points can't define that line. But a set of 2 points can. In other words, they're giving us not just these 2 points, but also these 2 points. So between both of them, I can come up. In other words, 3 points do determine a line. What's the general equation for an exponential function?
It's like a beats the x.
Very good. So let's put one of those points in. This one right here. Let's do A. In fact, let's do A part 1. So if you plug this point into the equation, what do you get?
Oh boy.
What's x? What's y?
X is 1 and y is 7.5.
Okay, so I have 7.5 equals a times b to the 1. Okay? Now,
A is just 7.5 though.
I can't solve for a based on that.
Why?
Why? Because I have 2 variables and I only have one equation. This one disappears and I have 7.5 equals a times b. Well, a could be 1/2, b could be 15, a could be 1/4, b could be 30. In other words, there's an infinite number of solutions to that equation right there. So I can't solve it based on that 1 point only. But give me another point. Well, they're telling me this point is on the same function. So let's write another one. Based
16.875 equals AB to the third.
Exactly. Now I can solve it. Why? Because I have two equations and two variables. Whenever you have two equations and two variables, you can solve it. Let's solve the first equation for A. What is A equal to in the first equation? This one.
7.5.
Divided by B.
Why?
Well, because we have 7.5 equals A times B. If I want to solve for A, I have to divide both sides of the equation by B.
Okay.
Now that I've solved for A as a function of B, I can substitute it into this equation and solve for B. In other words, I have 16.875 equals, well, instead of A, I'm going to say 7.5 over B. And I still have my B cubed. So now we have one equation and one unknown. We can solve for B. What's the next step here?
Make them equal to each other.
Well, they're already equal to each other. What can I do with B cubed divided by B?
Is it b to the second?
Okay, so now I have this. Now what's the next step?
We have to put both of them over b to the second.
Well, we're trying to solve for B. So what's the next step if I'm trying to solve for B?
Oh, divide by 7.5.
Okay, what is this number divided by 7.5? My guess is that, even though I'm not looking at a calculator.
It is.
Okay, how did I know that? What's the next step?
Find the square root of 2.25.
Exactly. And that's 1.5. That's why I knew that that had to be 2.25. So what's my equation? Now we've solved for B. Hold on, let's go back and solve for A. We know B is 1.5 and we know 7.5 equals A times 1.5. So what is A equal to?
Six?
5.
Oh.
7.5 divided by 1.5 is 5. So we got A equal 5, B equal 1.5. What's our equation that they're looking for?
5 times 1.5 to the x.
Good. In the final equation, you always still have the y, you always still have the x. All of our work has gone towards solving for A and B. And we did that. A was 5, B was 1.5, so we now have our specific equation for this problem. All right, they gave us a second point. That's a different equation. Still, y equals ab to the x. There's 4 variables there. What we need to solve for is a and b. So what's the first equation I can write? We're on
1.25 equals ab to the negative 1.
What's the second equation I can write? I'm going to need a second one because this is only one equation and two variables.
0.032 equals AB to the third.
All right. Now I have two equations, two variables. We should be able to solve this. Let's do it. What's my next step? First of all, what is A times B to the minus 1?
Negative A.
Well, it's the same as A over B, right? In other words, B to the minus 1 is the same as 1 over B to the 1. So I have 1.25 equals A over B. So what is A equal to?
Just 1.
Solve this. 1.25 equals A over B. How do you solve for A?
Divide the other side by B.
Multiply the other side by B.
What?
Multiply the other side by B. You always do the opposite of what's being done. What's being done is I'm dividing by B. So if I want to get rid of B, I have to multiply both sides by B. It's just like if I'm adding a number, you have to subtract it. If I'm subtracting a number, you have to add it. If I'm multiplying by a number, you have to divide by it. And if I'm dividing by something, you have to multiply by it. So I get A equals 1.25B. Now, using substitution, I can solve this equation. What's my next line? What's A equal to?
1.25.
B. 1.25B. See that?
Mm-hmm.
Okay, now what's my next line?
Um, 0.032 equals, I don't know how to do that.
Well, the cube is not operating on this part of the function at all. So I can just multiply everything together and I get 1.25b to the fourth. Make sure you see why that's true. In other words, I'm not cubing the 1.25. I'm only cubing the b. So b cubed times b is b to the fourth, and I still have the 1.25 there. What's the next step?
Put it over.
Trying to isolate b.
Divide.
There you go. So what is this number divided by that number equal to?
Um, 0.0184.
Now what is b equal to? What you have to do is take this number to the 0.25 power, or the 1/4 power, on your calculator. It's going to get bigger, not smaller. Put into your calculator, put this. Either like that or 0.0184 raised to the 0.25 power.
I don't have a raised on my...
What kind of calculator do you have, Grace?
I was using my... I don't know where my other one went, but I was using my iPod calculator.
Okay. Well, you need a calculator that has this being able to raise to an exponent. If we're going to be working these kind of problems, you definitely need that kind of calculator, because all of our problems are raising a number to an exponent. Let me do it on mine. So I have 0.0184 raised to the 0.25 power. I get 0.368. So B is equal to 0.368302. Well, I've solved for B. I can solve for A because I know 1.25 equals A over B. So I have 1.25 equals A divided by 0.368302. So A is equal to 3.3939. So I have A and I have B. So what is my general equation?
Y equals A, B, X. So
What is it?
0.03, no, yeah, wait.
A is 3.3939.
So 3.3939 times 0.368302.
To the X.
Yeah.
Okay, good. I think you get that, actually. Have a preference on what to do next?
Oh boy. Yeah, I don't know how to do 97.
Okay, well, that's definitely what we should do next then. First of all, what does this mean?
-2 times -2.
No, it means 1 over 2 to the 1. In other words, when you have a negative exponent, it just means the reciprocal. If I had 2 to the -3, it would be 1 over 2 cubed. This is huge. You have to know that. In other words, you have to know what a negative exponent means. Notice that a negative exponent has nothing to do with negative numbers. 1 over 2 cubed is merely 1/8. That's a positive number. In fact, by using a negative exponent, if this number is always positive, then it's always going to be positive, whether the next exponent is negative or positive. So now the question becomes, if negative exponent merely means reciprocal, what does that mean?
2 over 1 to the first.
Perfect. That's 2 to the 1 over 1, which is 2. In other words, we can take a negative exponent, and merely by moving the number to the other side of the fractional line and changing the sign on the exponent, that's what we want to do. So what does this become?
2 to the third over 1.
8. All right. What is this number? 1 over 2 to the negative 1?
Two to the first over 1, so that's 2.
And what is this number? The second part of that?
2 to the second over 1.
So give me a number instead of giving it to me like that. I mean, I'm glad you know that that's what it is, but it has to be translated to a number. What is 2 to the second over 1?
4.
And what is 1 over 2 to the minus 3?
8.
Good. And what is 1 over 2 to the minus 4?
16.
Good. Okay. What is the value of 2 to the minus n? Use the same exact logic that we just used.
2n over 1.
Yeah, it's just 2 to the n. You don't need the 1. $7.98?
Yeah, what's a conjecture?
It's a statement about how we would handle this. So tell me how you would write that.
A to the n.
So the conjecture would be that if you have a negative exponent, put it on the other side of the fractional line and make it a positive exponent. And that works every time. Okay?
Okay.
I hate questions like this because they require some sort of a explanation in English, which is not what math is all about. But A, let's find the domain and range. We have 3 points on that curve. Only. It's not a continuous function. It's only 3 points. So what is our domain? What can x be equal to? Domain is what x can be equal to. So what are the 3 values of x?
0, 1, and 2.
Good. Range is y. What are the 3 values of y?
Um, 1, 0, and -2.
Very good. How about B? This is not just 3 points. This is all of the points between here and here. But only that. Nothing to the left, nothing to the right. So what are all of the allowable values for x?
It's infinite.
No, because this is a closed function. This does not go in all directions. Normally you would be correct. All reals would be the answer. But because they have a closed dot there and a closed dot there, the only allowable values for x are between those two closed dots. So what are the x values?
-1 through +1.
Yes, and it's greater than or equal or less than or equal because of the closed dot. If that was an open circle, I would get rid of the equal sign here. What's the range?
0.5.
What can y do? Look at the lowest value of y and look at the highest value of y. What is it? Look only to the y-axis.
2 and -1.
Yeah, -1 on the downside. We always list the bottom first and then the top. Okay, how about C? What's the domain? What are the allowable x values? Now this arrow means it goes on forever. Stops right there, starts again there, and stops right there. So this arrow means that it goes all the way to negative infinity. So x is greater than negative infinity, but what is this point right here? What does x have to be less than? Do it in stages. In other words, this is a piecewise function. So do it from here to here, figure out the domain and range, and then figure out the domain and range from here to here. So let's do the left half of it. The x values goes from negative infinity to what?
-1.
And notice that it's just a less than. There's no equal sign because that open circle right there. And what else can x be?
-1 and 3, 2.
2.
Yeah.
Good. So range. Let's talk about range. What can y be on the left part?
Infinity.
Well, let's start on the bottom. When you talk about domain, you go left to right. When you talk about range, you go bottom to top.
Oh. -2.
Well, yeah, let's do it the correct way. In other words, I said the left part, but if we're going bottom to top, we need to do this part here. So it goes from -2 to what? What's this point?
2.
-1.
What? Where?
Right
Oh,
here.
okay.
Remember, we're looking at the y values.
Right.
And how about these y values here?
Wait, where?
Well, we got two parts to this function. We got this bottom part and we got this top part. Both parts are going to contribute to the range. We just figured out the range of this bottom part. Now let's figure out the range of this top part.
-1 to infinity.
Yeah. And notice my inequality signs. They match the closed dots and the open dots perfectly. And when infinity is in one of them, you always use the less than only. You don't use greater than or equal to infinity, ever. Now, have you had something called interval notation?
I think so.
Well, let's talk about each of these in interval notation. Let's go back to this one right here. In interval notation, this is bracket -1, comma 1, another bracket. Okay? The range is bracket -1, comma 2. You with me?
Yeah.
Let's look at this one. Interval notation, first of all, whenever you have the infinity sign, you always use parentheses. It goes to -1, and because that is just less than, it's parentheses. And then I'm going to combine it with the second interval, and the second interval is this one. Well, the second interval has a bracket on the left side because there's this less than or equal to. And then the other half of that was infinity, I think? Yeah. Infinity always has that. So when you're dealing with interval notation, if there are two distinct intervals that are different from one another, then this is the way you handle it. And what would the range look like?
-2, comma -1.
Parentheses or bracket?
Bracket.
Combined with parentheses or bracket?
Bracket.
Parentheses.
Well, no. Okay. Infinity.
Like that. Okay? All right. And do you want to do D, Grace, or do you want to go on? I ask because we have 15 minutes and I'm not sure how deep you want to get into this stuff. Do you want to do D? We need to define the domain and range on D. Actually, D is pretty easy to do. Let's go ahead and do D. What's the domain? In interval notation.
Infinity? Is that an arrow? I can't tell.
Yeah, it is.
Okay.
In other words, it can go from negative infinity to positive infinity, which is also called all reals or double R, like that. In other words, x can be anything. There is no limitation as to what x can be.
Okay.
What is the range? What can y be?
-1. bracket -1
Good.
to infinity.
Good.
So, and then parentheses.
Uh-huh. Okay. I think you get that.
Can we do 7/100?
Sure. When you have these fractional exponents, do the denominator first. In other words, this means I'm going to take the cube root of 64 and I'm going to square the answer. That's what it means. In other words, it really means the same as this. Cube root of 64 squared. Okay? But if you square 64 first, you have a huge number. And then you have to take the cube root of that huge number. So the only way you could do it if you did it that way would be to use a calculator. But all of these, if you do the bottom first, let's take the cube root of 64 and square that answer. It's much easier to do. What's the cube root of 64? Remember, it's
4?
always going to be one of those small whole numbers. So it's 4 squared, or 16. Notice how much easier it was to do when we took the cube root first. We didn't have to deal with 64 squared at all. What's 25 to the 5 halves?
The square root of 25 to the 5th.
What's the square root of 25?
5.
So it's 5 to the 5th. And I believe that that is 5 times 625, which is 3,125. And finally, what is 81 to the 7/4?
The
Fourth root of 81?
yeah, to the 7th.
Right, but the fourth root of 81 is 3. 3 times 3 times 3 times 3 is equal to 81. So it's 3 to the 7th, and I don't know what that's equal to, but your calculator would be able to tell you.
Okay. Oh, and I can do 7/101.
Well, that's good, because I can't. This must be this is the way they're teaching you to factor, apparently.
I guess, but basically, like for A, you do -4 times -7, and you get the top
28.
little diamond thing.
Okay.
And then you do -4 plus -7, and then you get the bottom diamond.
Okay. All right.
So for C, would it be a half and 4? Because a half times a half, no. Is a half times a half 1?
Well, I'm not used to doing these, so I need to kind of look at it. So we have a minus 12, whoops, excuse me, you wanted to do C. So we have minus 8, and that's a half. And you said this number times this number has to equal that number, right?
Yeah, whatever, a half times whatever equals -8.
Is that right? 1/2 times -16 equals -8?
Yeah, I think so.
And then the bottom diamond is 1/2 times -16? No, that was the top diamond. What's the bottom?
Yeah, that's plus.
So 1/2 plus -16?
Yeah.
Okay.
Okay. That's weird.
It is a little weird. The question's a little weird. I have never particularly cared for the California method or the diamond method for factoring. I think it's more confusing than it is helpful. But that's not for me to decide.
Yeah.
So we got 10 minutes. What else you want to go over?
Can we go over D?
Yeah. Are you sure you got the formula right?
For what?
That the top square is the product of these two things and the bottom square is the sum.
Yeah, I think so, because if you click on that, like, click on, like, it says you're multiplying x times y, like, over here in the top right corner. It says x times y, and you get xy,
Okay.
which is at the top.
I got it. Okay, I
X
see
plus
now.
y.
Yeah, I see. So, yeah, that definitely appears to be right. So what's the top diamond?
Is it 1/10?
Uh-huh. And what's the bottom diamond? What's 1/2 plus 1/5? It's much harder to add fractions than it is to multiply them. Find a common denominator.
10.
Okay. How many tenths
So,
is 1/2?
5/10 and
How many tenths is 1/5?
2/10. So 7/10.
That's how you do it.
Wow. Okay. I guess since we have so much time to spare, we can start on 799.
799. Is that just the next one?
It was before the one that we were at. No, it's 7.2.2 where we were.
Oh,
and
okay.
it's down.
Oh, going backwards. Okay.
Yeah.
Okay. So we have f of x being 3 times 2 to the x power. What is f of minus 1?
-1 equals 3 times 2
No.
to the
In
negative
other
1.
words, whenever you see this designation, what you want to do is whatever's inside the parentheses, plug it in for x. So it's the same as this, which is the same as this, which is the same as that.
Okay.
Okay? It's an important concept in math. In other words, when they give you a function as f of x, and then they say f of some number, you always want to plug that number in for x.
Okay.
What is f of 0?
3 times 2 to the 0.
Which is?
3.
Good. What is f of 1? Ooh, my computer's acting weird.
6.
Good. See, once you know these, they become a piece of cake. What value of x gives f of x equal to 12? So I'm saying f of x equals 12. F of x was equal to 3 times 2 to the x. So how am I going to solve this?
It's 2 because you have to do 2 times 2, which equals 4, and then 3 times 4 equals 12.
Right. What we're going to do is substitute 12 for f of x. So we have 12 equals 3 times 2 to the x. Next step is to divide both sides by 3. So I have 4 equals 2 to the x. Well, x clearly has to be 2.
Okay.
Where does the graph of this function cross the x-axis? Well, our function is 3 times 2 to the x. So first of all, what does it mean when it's crossing the x-axis? What is f of x going to be when it's crossing the x-axis?
We don't know.
Whenever something crosses the x-axis, f of x is 0.
But I thought y was 0 when something crosses the x.
It is. Y is the same as f of x. I could have written this just as easily like that. Whenever you see y and you see f of x, they're one and the same.
Okay.
So if I want to know the x-intercept, I set y equal to 0. Is there any value of x that will make that equation true? And if so, tell me what it is.
It's got to be a negative.
Well, now hold on. Negatives do not make negatives. No matter if I put an x negative in there, I'm still going to get a positive value for 2 to the negative x.
So then no.
You're right. No is the answer. So there is no x-intercept. Okay? What is the y-intercept? Again, a very important concept in math. The x-intercept is where y is equal to 0. What is the y-intercept? Where x is equal to 0. You get that? In other words, if I have a curve, the y-intercept is where my x value is 0. Right?
Right.
My x-intercept is where my y value is 0. Always remember those two things. That's what x-intercept and y-intercept means. So if I want to figure out what my y-intercept is here, what am I going to let x equal to? Zero. What is 2 to the 0th power?
Just 0.
No.
Or 1.
1. Very big difference. Because that's 1, y is equal to 3. So I do have a y-intercept of 3. I do not have an x-intercept. In other words, if I were to graph this, it would look like this. Notice that there's my y-intercept right there. It's at 0, 3. Where's my x-intercept? I don't have one. It never crosses the x-axis.
Okay.
Okay? All right. Grace, I'm proud of you for working on spring break. I don't have very many students that have scheduled sessions this week.
Thanks.
But I'm impressed with the ones that are. It shows you really want to learn it, you want to understand it.
I do.
Good.
Thank you.
I will talk to you next time.
Okay.
All right. Bye-bye.